What does it say to do? Yes, sir.
Prove A and C equals M C.
I'm saying with the progression sheet. What does the progression sheet say to do when you have a bisect? Miss Hannah, what do you got? This is a segment bisector, though. We have segment bisector on there, right? Yeah. All right. So on your progression sheet, I believe we talked about it and said segment equals segment. Now, from yesterday, when we did a little bit of that definition of congruency, can I say segment congruent segment? Will that change anything? Is it okay to say segment equal segment or segment congruent segment? It doesn't change anything. So you can do either or for this. So now we have AT bisects MH, which means I'm going to say segment congruent to segment. Well, bless you. The two segments that were made congruent to each other are MT and TH. So, oops, MT congruent TH. What do you think the reason is? What does it say it is according to your progression sheet? Definition segment bisector. Bless you. Okay. Have I fully utilized that given statement? That first part, that first definition? Yeah, there's nothing else I can say about it. So I go to the second one. AT is congruent TH. Given. Mark the diagram. What is it asking you to prove? Correct. Don't we have that now? How? How do we have it? The little lines are showing us that they're equal, but according to our proof, look at what you have. You have TH equaling two different things. Therefore, what do? Substitute. You're done. Done. That's it. That's all it was. Boom, boom, boom. Done. In this case, all you had to do was come up with one step on your own. You only had to come up with one thing on your own, and that step was the substitution step. Everything else was either given to you, or it was written up in such a way that you could follow your progression sheet. Okay?
Did you just write down a whole bunch of stuff to make it look like you did that? Well, that's not the question I asked, but did you just write down a whole bunch of stuff on here just to make it look like you did that?
No.
Okay, because I didn't assign that.
That's what I was wondering. Again, make sure you have your progression sheets out in front of you. Make sure you have your reason bank out in front of you, because this proof is eerily similar to the one we did yesterday where we had to add in the middle angle. Remember how we had to define the angle and add it to both sides with an equal sign? We did this proof yesterday. It just looks different. You're going to see this a lot, guys. More and more times, you're going to have basically the same style proof that you had in a previous example. There's only so many of these things out there. They're kind of the same thing over and over again. Okay. What's your first thing to do? Given. It's a good place to start. Given. We know that 1 is congruent to 3. And what should I do to my diagram? Mark. Very good. What did they do to the second step? Definition of congruency. Now, remember, definition of congruency works when you have to switch from congruent to equal or equal to congruent. Because, and that's what we talked a lot about the past couple days, is that anytime that you have math, adding, subtracting, multiplying, dividing, it always has to be an equal. It's not within congruent. That's the reason why we have that step. So this is your definition, congruent. You don't need to write out the word. Symbols are fine. I try. Oh, shut up.
Sorry.
It's okay. Why is 2 equal to 2? Very good. Very good. Very good. Whenever you... Yep. Yep. Reflexive. Do I really... Is it the end of the world if you don't put the word property after that?
Yeah.
No.
Oh, sorry.
It's okay. Is it perfect that you write property after it? Absolutely.
Yeah.
But is it the end of the world if you don't? So now look at what they did. In step 4, what did they do to what they had originally in step 2? They put them together. So did they add the same thing to both sides of an equal sign? What is that called? They're adding the same thing. No. No, they're adding the same thing to. No, hold on. Stop and think here. Yes, add prop equal. They added the same thing to both sides of an equal sign. Notice this 2 was added to here and to here. They just added the same thing to both sides of an equal sign. Bless you. Add prop equal. It's not going to be, it's not going to be angle addition here because they're not saying that 2 smaller angles equal a bigger angle. Does that make sense? Bless you. So it won't be angle addition because 2 smaller, they're not saying that 2 small equal a larger. That happens to be the next step. Everybody see that? This next step says that 1 plus 2 is this whole angle. 2 plus 3 is that whole angle. Okay? Everybody see that? That's angle addition. Remember, angle addition is basically when you're going to see, same thing with segment addition, when you see angle plus angle equals another angle, or segment plus segment equals another segment, that's a dead giveaway. It has to be segment or angle addition. If it's just angle plus angle equals angle plus angle, that could have been a substitution step, or it could have been an add prop equal because it adds the same thing on both sides. That's the subtlety of these things. That's what you're looking for. So now you have your angle addition. Now what do? Excellent. Substitution, because you already had 2 things that were equal to each other, therefore they're equal to other things. And last but not least, definition of congruent. Very good. Okay? Now, I'm hoping that most of you guys are probably not too far behind on these now, right? They're not becoming as scary as they were 2 days ago. Hopefully, maybe. And it's okay. It takes time. It's all right. It's okay, guys. It's not a big deal. So let's do this one. We have, like I said, I've got 3 progressions to work with. So let's start with one before we continue on the rest of them that are on that sheet. Actually, there's only one left on that worksheet that we have. Because the other ones deal with triangles, and we're not ready to deal with triangles yet. So let's do this. If given perpendicular, this is one of the most common ones that you see because this, if given perpendicular, will allow you to tell, you can get like 3 things out of it. Okay, you get about 3 things out of it. So here's what we're going to do. If given perpendicular, we're going to do this. We're going to state the right angles that are formed, and then we're going to say that right angles are congruent. We're going to do 2 steps with this. Okay? We're going to do 2 steps. Excuse me. is perpendicular to CD at point X. We'll just write it out like that. So before I do that, before I get into what I'm going to state, what will that look like? AB is perpendicular to CD. Well, AB perpendicular to CD at point X. Oh, you know what? Let's do it this way. Let's not put in that point X. We'll just call it we'll just say AB is perpendicular to CD. That'll be easier. We'll make it B here. Is it okay if I do it like that? So, when things are perpendicular, what is formed? Right angles. So what we're going to do, this is our given. So now I'm going to state the two right angles that are formed. In this example, what are the two right angles that are formed? CBA and DBA, or ABC and ABD, does it matter the lettering that you use? What has to be in the middle though? B. Very good. So I'm going to do it this way. Angle ABC and angle ABD are right angles. Why, bless you, why are they right angles? Because they were perpendicular, okay? So what do you think my reason's gonna be? Definition of perpendicular. See how it's kind of keeps strolling along the same way here? So it's definition perpendicular. Now the next part is the second portion of it. What do you know about all right angles?
90 to equal 90.
They equal 90 degrees. So if all right angles equal 90 degrees, they have the same measurement. Angles that have the same measurement are therefore then
Congruent.
congruent. Very good. They're going to be congruent. So we put in our boxes right away. So might as well state that. Our second part then would be is angle ABC is congruent, angle ABD. And now this is a little bit different. All right angles congruent. That's all you got to write. This is going to be a tremendously helpful progression as we get into triangles, guys. It is something we're actually gonna have something later on called a perpendicular bisect. Not only is it perpendicular forming right angles that are congruent, it'll bisect the segment as well. So you'll be able to say all right angles that are formed, right angles congruent, segments are congruent. So you're gonna be able to say after that one given, you'll have 3 statements. You'll get 4 things out of one piece of information. So that's the idea as we're starting to build into this stuff. By putting these things on our progression sheet, we can go ahead and do all that. Okay? Not bad? Okay. Let's do another one, which is a offshoot of this, just about right angles. Nope, we already have some about supplementary. Okay? Let's do another one then about right angles. Are we okay with perpendicular? I think this one kind of makes sense because we know right angles are all 90, right?
Yeah.
I mean, am I correct?
Mm-hmm.
They don't get much funnier.
No.
They really don't. Okay. If given right angles. If you're given right angles, what do you think you're going to say? Well, what do you know about all right angles? They're 90 degrees. So all right angles are congruent. That's all it is. So what I want to do here, if I'm given right angles, I'm going to state right angle congruent to a right angle. Basically what I'm looking at. So sometimes you'll see in a proof that you'll be given the angles 1 and 2 are right angles. Well, what do you know about angle 1 and 2 then? They're congruent. That's about it. Okay. It's just a little offshoot of the one that we just did. It does show up from time to time. That's why I wanted to throw it out there. So we'll just say this. Our example, angles 1 and angle 2 are right angles. Make it silly, silly simple. If that's given, what? What? If that's given, what am I going to say? They're congruent. Which ones are congruent? There you go. And look back at the progression we just did with the right angles. What did we say about right angles after? If we knew we had right angles and we knew they were congruent, what was our reason? What do you think I'm going to use now? Yep. Okay. Do I need a diagram, or are we okay with that? Probably get away with using the same one we just did with perpendicular, couldn't we? Okay. Let's do another one. Vertical angles. Remember what vertical angles are?
Yeah.
So what were they?
I wouldn't know.
Angles are opposite each other. What do you mean? Very good, very
Okay,
good.
sir, stand up.
You got it.
Keep up here. And just face the board. So on his shirt, the vertical angles would
Ooh.
be here and here, and then here and here. Right?
Fancy.
Like, they planned this, like, that was great.
He got up and was like, oh crap, what did I do wrong? That's exactly it, guys. So vertical angles are stuff that sometimes you're not going to be given. Sometimes it's something that you can find within a diagram. So here I'm going to say, look for. Okay? Vertical angles generally aren't given to you. Vertical angles are something that you can infer from a diagram. All right? That's something that you can infer from a diagram. So let's say, for example, we had, we'll call this angle 1 and 2. Now, if it's not something that's given to you, but it's something that you can make an inference off of a diagram, which is completely legit, you do this a lot. What would happen here is, if I notice that 1 and 2 are vertical angles, I can say, angle 1 is congruent, angle 2, Mr. Pitts, stop it. I can say that angle 1 and angle 2 are congruent right away because I know that vertical angles congruent. That's it. It's a very common thing. I would say this, vert angles congruent. Now, lettering, numbering, however it's set up within a picture in some diagram, every one of them is going to be a little bit different. But if you ever have the two lines that are crossing each other, no matter what, when two lines intersect, you're always going to have minimum, well, you're only going to have 4 angles. And of those 4 angles, 2 of them are, there's only 2 measurements, no matter what. Okay? You can only have 2 different angle measurements because of laws of supplementary and linear pairs, all that kind of mumbo jumbo stuff. Okay? Sure. Yeah, it's in a thesaurus somewhere, I think. Why did yesterday think, I thought yesterday was Friday. That would have been great.
I mean, same, like, I thought that
Because it was
was
half day. I'm like, ah, let's just go.
Mr. Murphy.
where we are.
Somebody would come to school.
Where's the
night?
so funny? You care to inform me on the joke?
We had late start Wednesdays.
I hate late start.
We should do late start like every day.
No.
We should do like a
Actually,
late
No.
start. So like you come here for
Then you
30
get out
minutes.
earlier during the day. You have more time. You have more daylight.
So let's utilize what we just did with those 3 fast progressions. Let's utilize those last 3 progressions and work through this very last proof. Let's work through this last proof because this is where they come into play. Excuse me.
First and second ones are givens.
No,
Only the first one.
just the first. Oh, are you meaning like these first 2 parts here?
Yeah.
Okay, yes. No, I thought you meant the first 2 statements. So, again, one of the things that a lot of textbooks and stuff like that do, which I'm not a huge fan of, is that they combine givens. Personally, I don't do that because then I might forget one. And that happens a lot. So, in this case here, what I would say is that we know that you've got 2 givens. You got perpendicular, and then we've got complementary angles. So what they've done here is they've utilized both givens in a different sequence of events. It's not a big deal. Like I said, it's just how they're setting them through. Okay. So if I say that these 2 are perpendicular, and those 2 are complementary, my reason is givens. Bless you. So now if I look at it, why can I now say that angle ABD is a right angle? According to our progression. Yes, sir. Look at your progressions. Look at your progression. What does progression say? No. Definition perpendicular. Our progression says state the right angles that are formed. Well, in this case, there's just 1. So I can't really say that it's congruent to itself. I mean, it could, but I don't need to. Okay. So now I look at it to the next part. Why is 2 and 3 equal to 90? Look at your progression sheet. What did they use to get that? Gentlemen, come on. Look at that statement. 2 and 3 are complementary, which means, hold on, definition complementary. On your progression sheet, you have something that talks about complementary angles, right? It says angle plus angle equals 90. So, according to the sheet, angles 2 and 3 have to add up to equal 90 because that's what it says. It should be in your progression sheet, yeah. Was the which one? 4th one, yeah. Yeah. So now they told us this. That's why we can say, oops. That's why we can say this. So it's definition complementary. Okay. So now look at what you have. It says angle 1 plus angle 2 equals angle ABD. Angle addition, very good. Notice, 2 angles equal a different angle, which means it should probably be angle addition. Now, why does angle ABD have to equal 90? Because it's a right angle. Back here, we said it's a right angle, so you can use this. So on our progression, let me go back to that real quick with right angles. We have right angles formed, all right angles congruent. Sometimes,
Which one was that?
right angle ones. Every once in a while, you might have to do like angle 1 equals 90 degrees, and that might be, a definition of a right angle. And that's completely fine. Every once in a while, you might have to do that. So on our progression sheet, there's a couple of different things you can say from a right angle. If you know you have a right angle, if you know you have two of them, you know they have to be congruent to each other. If you have one of them, you know that it has to equal 90 degrees. It's just something that does show up from time to time. If you have both of those quick statements within your progression sheet, that would be probably be very helpful. Okay? That way it's there. So back to the other one. Why is it equal to 90?
So if it's,
But you can do that one, but a lot of things you don't do a lot of addition stuff like those. Because of
Right.
and it's fine. It's,
Okay.
yeah, absolutely. Yeah, that's fine. So I'm like running into you, but I can't see the board.
Whoa, calm down, man.
Why does 1 plus 2 equal 90 in this weird universe?
Wait, what?
We're talking about angle 1 and angle 2 is equal.
Oh, there's a right angle, so you know.
Hey, don't steal my thunder.
Well, we haven't done that yet.
What thunder?
It's more thunder than what you have.
Enough, both of you. Guys. We go back to where we started. We have a right angle. We use complementary. Angle addition to show that two angles add up to equal ABD. We know that ABD is a right angle, which means ABD have to equal 90, which means the two angles that make up ABD are also add up to equal 90. Substitution. Now, again, what's the next step? Look through where you have a bunch of stuff. I have angle 1 plus angle 2 is angle 2 plus angle 3. Well, look back into the proof then where you have something written about angle 1 and angle 2. Look back where you have something written about angle 2 and angle 3. Very good. Because here you have angle 2 and angle 3 is 90. Here you have angle 1 and angle 2 is 90. Since they both equal 90, they have to equal each other. So we use substitution. And then the next one, they got rid of the 2's, so it is subtropical. Subtrap.
What are we talking about?
Prop.
Florida?
No.
And then last but not least, so if we just go back and look at what you had here, one of the things that happens sometimes when you have proofs, if you have more complex things given to you, like perpendicular or complementary things, a lot of times with those, you're gonna have more steps than you would normally because there's more things you can say about them. So it's not uncommon that that happens, okay? Questions at all? Okay. On the front page of this, you guys have 10 statements. On these 10 statements, you're given some information. You should then know what to state about that information and the reason why you state that about the information. What I want you to do today, for the weekend, is to figure those 10 things out. It will be extraordinarily helpful for you to draw pictures of what is going on and to have your progressions right next to you. Because as you know this, you can bounce to your progression and fill in the next two parts. that's what we're going to be doing, is then next week we'll do proofs totally on our own, because I don't think we have enough time to start that today. Okay, is that fair?
I guess.
So, you got those 10 things to fill in. Use your progression sheet now. We've got, hey look, time works now. You got about 12 minutes or so to get going on it. Go ahead and get started, okay?